Thank you all for having me. Thanks, Naresha, for the kind words of introduction. I know it's a session after lunch. I hope not to lull you to sleep, but yeah. So I'm Hari. I'm the co-founder and CTO of Specmatic, like what Naresha mentioned. I am a transformation advisor, coach and a trainer, and largely for the past few years, I've been focusing on this area called API governance strategy. That apart, I love being at conferences, and Agile India was one of the first conferences where I ever presented 15 years ago. So it's great to be part of this finale. And again, I thank the organizing committee for giving me this opportunity. So, and these are some of the other conferences I volunteer at, speak at, and hold dearly. So there's quite a few more, but I just mentioned a few here. All right. So I also happen to be the ambassador for Async API specification, which is trying to capture the event-driven architecture, quite similar to how OpenAPI is trying to capture RESTful APIs, right? So that's something that I do on the side also. I'll stop ranting about myself now, and let's get into the topic for today. So we all heard of representational state transfer, REST, and I'm pretty sure we're all familiar with this gentleman. How many of you can identify who he is? Anyone? He's Roy Fielding, and it's his dissertation which introduced the term called representational state transfer. And of course, it's got all the great stuff, right? Everything is a resource, interactions are stateless, use of standard HTTP methods, predictability through uniform interface. Of course, you have like plurality, the CRUD, all of that came out of this dissertation and paper. It makes it so much more predictable to work with an API when you know how all the resources are named in a certain way, right? And of course, you don't reinvent the wheel, but more supportive of a layered architecture. And ultimately, this term should also be pretty familiar, the HETIOS, which is basically hypermedia as the engine of application state. Sure? So you've heard all of this, right? All the buzzwords, pretty much REST, HETIOS, everything in one slide. So now, I have a question for you. How many of you would consider your APIs RESTful? Put your hands up, please. Even whatever it is, what do you consider as RESTful? No one? Wow, I thought there'd be more people. Okay, so that's actually interesting. So now let's turn this table around, right? If I was thinking that if a lot of people are going to say it's RESTful, then I would have asked how so, right? But now I'm probably going to say maybe you're RESTful, but you're RESTful in a certain way, so you should be happy about it, right? How do you say you're RESTful? How do you define it? That's when you get Richardson Maturity Model. This gentleman, who is Leonard Richardson, and his beautifully put together article about how you can think about RESTfulness in the various stages, right? Again, I'm trying to give you a sense of all the aspects to think about when you're thinking about API design, so that when we get into the API design anti-patterns, we're able to qualify what an anti-pattern is basis the theory that is behind it. So Richardson Maturity Model has technically 4 levels. Level 0 is basically a swamp of POCs, right? Practically that's the starting point. And then resources for level 1. Level 2 is HTTP verbs, and level 3 is HETIOS. Okay, so let's look at this in a little bit more detail as to what are these levels. So what does a POCs API look like? You have a single endpoint. You notice I just have a /API, no differences there. Pretty much if you have to create a product, order, delete a user, or for that matter even within product, create and list, both operations are right there. Everything goes through a single endpoint. I simply use post for everything, and I just get a response. All good, right? Sounds familiar? Practically remote procedure call. Nothing fancy here, right? Just RPC, but over HTTP. It's going to accept XML or JSON payloads, and a single endpoint just makes it very, very easy to build and run. But then the disadvantages, right? You don't have any resource separation. Worse, you don't use HTTP verbs at all, which means I cannot use the middleware efficiencies like caching. I cannot say HTTP get can be cached. I cannot make use of that. And of course, because the status is not there, you have a fun little activity of inventing your own error codes. You would think about whether it has to be text, error warning info, Or you want to think about error codes, should I start with 1000 or should I start with 10,000? Those are all very fun decisions to make, right? But then that's the whole point about POCs, right? Then comes level 1, which is resources. All I have done at this point is instead of having that one single slash API, I have separate API endpoints for each resource. And this, in my opinion, is an order of magnitude improvement over a POCs. Why so? Because I still do like all the standard stuff, right? The post, I don't have HTTP verbs, I don't have return codes, I'm not respecting HTTP return status codes. But that said, just by virtue of having this separation, right? If this is a monolith, I now have the possibility that I can potentially pull this out as a service or separate it. So it gives me that opportunity. That's where level 1 is still great. And that's why I was saying like, the gentleman over there was like, I was not sure if it's REST or not. So if you're here, it's still like REST level 1, right? We could say, yeah. Level 2. At this point, you have like a further order of magnitude improvement. You have HTTP verbs. The beauty of using HTTP verbs, which means I have get cacheability and whatnot. I have status codes, which means I don't have to invent my own status codes. I can deal with the 2xx, 3xx, 4xx and so on. And technically, for me, this is the sweet spot for most APIs. If I can even do level 2, I'm in really, really good position because I'm using middleware, I'm using HTTP infrastructure to its fullest advantage, and largely I'm there. It's very easy to follow. It's very predictable. You know the pluralization of my resources. It's standard CRUD. So all the good stuff. If we are all happy at this phase, why even bother with this? Level 3, heteros. Someone know what does it mean? Like what is hypermedia's engine of application state? Someone wants to take an opportunity to explain what it is? Anyone? No wrong answers here. Okay. Right. Hypermedia as the engine of application state. What does that mean? Links to understand what actions to take next. So typically, if I'm creating an order, I get back to 201 and then the consumer decides what URL to hit next, right? But instead, if the server tells me these are the possible actions you can take next, maybe after this order is created, I could fulfill it, or maybe I can verify the deliverability of it, or I could do a price check or something like that. But that is something that the server decides. It's not the consumer. For example, the advantages are there's no hard coding of URLs in the client. The workflow is managed by the server, which is really, really important, right? For example, let's say you're doing an A/B testing between fulfillment services. You have one service and a cutover service instance. Now the server can decide to which consumer they want to give which one, right? I could potentially say, hey, this consumer is coming to me from this particular geographical location. I could give him the link to the fulfillment service, which is probably more sensible to them. Or I give a link to some other fulfillment service. That's more of a technical context, right? Or in a business context, I could say, hey, you need to go directly to fulfillment or you can go to something else. That workflow is now managed by the server, which means the consumer does not have to change their code once they're built to it. That's not easy, is it? Because the links, I need to have intelligence both on the server side and on the client side in order to do this. And there's a significant learning curve. I mean, I think I've probably done one Heteos API, but I don't know whether I shipped it fully to production or not. But how many of you have even seen Heteos APIs within your organizations? Anyone? Awesome. Yeah. Yeah, that's usually the answer, and exactly. So that's a beast which we all want to see, right? But it's more like that elusive yeti which we never get to see. Few examples in the wild is PayPal, GitHub. There are APIs which I'll share the slides after this, you can check them out, how they manage the workflow from the server side. If this is so complicated, right, why are some people even going after it? Why are they even thinking this is so important? Any guesses? Yes? Yeah. Yeah.
makes it possible
Yeah.
to change the URL without having to affect the client.
Exactly. And it only makes sense, at least what I little understand, is the volume of consumers dictate this architectural decision, right? If I am just an internal API, which the consumer sits across the table, probably not worth doing all this complexity, right? But for someone like PayPal or GitHub, they have hundreds of thousands of consumers, and even the consumers don't want to keep changing their code once they've written it, and for the provider they want the freedom of being able to evolve, right, and make the workflow decisions on the server side without having to or constantly bring the consumer up to speed on that. So that's the cost advantage, right? So that's the Richardson Maturity Model. So now maybe I'll ask you the question differently. How many of you have level 1 REST APIs? No. Level 2? Okay, level 2. Awesome. So good stuff actually. Level 2 is where I feel is the 80-20 of a API design for as far as HTTP is concerned and REST is concerned, right? Majority advantages. The last 20%, it really depends whether you want to go the length for heteros. Okay, we looked at REST and we looked at the maturity models, right? Now let's look at this gentleman. Obviously his second name is right there, but anyone else recognize him from something else? Okay, this is John Postel, and he is one of the primary authors of the the TCP RFC for as part of DARPA. And this principle, the robustness principle, comes from that particular RFC. Be conservative in what you do and be liberal in what you accept from others. I'll let that sink in. Conservative in what you do and liberal in what you accept from others. And this is almost like a statement for an API designer, right? How do you think about this? For example, tolerating extra fields. I only need 4 inputs to create an order. The list of products, the delivery address, the mode of payment, and maybe the name of the person, right? But what if that person is also sending me, maybe where I'm ordering it from or something like that, additional fields. I can choose to drop them, or I could complain that no, I was not expecting this field, why are you sending it to me? The tolerance level there, right? Ignoring query parameters which are additionally sent to me, potentially. Allowing default values for some fields. Maybe my consumers are lazy, they're not going to send me everything that I'm asking them for, so I have smart defaults. Now why all this? Why do you think this is a good idea? Why do you think this became such an important thing, Postel's principle? Extend? I got it, okay.
Additional parameters you can extend basically. You can allow user to send more parameters on the later on, and you can accept, and you don't have to change the specification for that.
Interesting. Yeah, but they're sending me stuff which I don't want, actually speaking. So that's the point, right? But I'm still. Very good point. But all of you, why? Okay, let me put this out a little bit differently, right? I only need the 4 fields. The remaining fields that are coming, I'm only going to junk them. I have another choice saying, don't send me extra fields. But if I do that, then I'm always giving a problem. Yeah. Exactly. Yeah. It's a no-op, technically.
Plus, that I think you can use that to understand your customer better. If you get a field that you don't use, you might think about implementing it.
Potentially, yes. But interesting. Forward compatibility is an important point. Potentially injection. Yeah. But if you think about it, right, that's. Yeah.
So it will just load up
Correct.
on the server side.
Okay. So let's look at the alternate approach, right? Let's say I'll take this gentleman's answer of saying, I have a security concern through those additional fields which are coming, and if I potentially choose to store them, and I could have a security concern, so I want to reject it. So every time someone sends me an additional field, I'm going to say no, this is an error. And if I do that, what do you think will be my adoption? Does it affect my adoption? That is the bigger problem. Like exactly. The issue is if I'm a new API product which is trying to get into the market and consumers are adopting me, the first thing I see is like, no, you're not supposed to send this. No, you're not supposed to send this. There is going to be friction. So if I'm lenient, I'm allowing them for like, okay, you send me whatever you want, but I'm going to be like, try and work with what you're sending and make the best of the case and move forward so that I can increase adoption. So Postel's principle is coming from the point of view that, if you're flexible in accepting others, it goes a long way in supporting a lot of consumers and get them adopted, right? So the robustness principle is positive implications. I have high levels of tolerance, resiliency against minor deviations. I don't want to be a tantrum child, right? Like every time, no, I want exactly that flavor of ice cream. I don't want to be that child, right? So that's what it means. So, but what about the negative impact? Implementation complexity. So one example I can give you from my experience is there was a date field and we would constantly see some consumers sending an RFC format of the date and someone else would send an ISO standard date format. Now we did not want to complain, go this way or that because the consumers might drop off. They might say, no, we're just probably not going to use it, right? So what we internally did is we detect the format and then convert it to a base format and use it. But that's so much more hard work, right? Why would I, what is the, but that's the cost that comes with increasing levels of tolerance. Anyone heard of this term, Hyrum's law? Okay. This gentleman is Hyrum Wright. He's a Google engineer. I don't know whether he's still at Google, but he came up with this thing called Hyrum's law. And it's one of those pearls of wisdom, right? Which you look at it and it's like or rather just one sentence and it's extremely dense with wisdom. So this is the sentence. So here it goes. With a sufficient number of users of an API, it does not matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. I'll let you reread it. Yeah? So it's not the written word. It's just anything that's observable behavior is come to, it's not just APIs, right? Even as people, we behave in a certain way and, suddenly if I change my behavior, it's like, hey, last week you were not like this. It's something that I constantly get, right? But am I breaking something there? So that's the same that goes for APIs. Examples. This seems pretty silly, right? Orders of fields in JSON. Like JSON is unordered anyway, but I've seen this issue happen in the wild because what happened is this particular serialization library that we were using serialized the JSON in a certain order, always. And the consumer had somehow written a library or custom parsed that JSON to expect a certain field at a certain position. And we changed the library for serialization and the fields went haywire. While it's perfectly fine for the JSON to be unordered and it's not expected, right? But the consumer starts complaining, hey, something's broken. Like then we ask them, why are you depending on the order? But that's the behavior that's come to play out, right? Response times. I have a 500 millisecond SLA with the client, but I'm usually responding within 100 milliseconds. So they have not even accounted for what if I go to 400 milliseconds. Messages per unit time. I'm putting 10 messages on a Kafka topic every minute. Anything beyond that, maybe they don't even have buffering capability to tackle it, right? So these are all issues which, what do you think this affects? Like if I change these things, these behaviors, these unwritten, not so word of, contractual behaviors which people have come to depend on, what is the impact of it? Lack of flexibility. Anything else? Correct.
Which essentially is not a problem per se. It's not your problem to solve, but still the adoption will go lower if you say that I'm not going to handle.
That's a very good observation comparing Hyrum's law with Postel's principle. But if you're just doing Hyrum's law, look at it from the merit of Hyrum's law. What is the impact of breaking this? Like impact of this situation? People have come to depend on my behavior, which I have not written it. Backward compatibility. So I believe I am not breaking anything, right? I have not put it in my contract that JSON is going to be this way in this order, right? I am saying it's a JSON, so I assume it can be in any sequence. I move forward. Pagination for that matter. How many items per page? I am returning 10 today. Tomorrow I might return 20. But that's my choice, right? I never said that this is the default. But people have come to depend on the fact that I'm always going to send 10, right? So now, even if I change the numbers, I inherently end up breaking backward compatibility even without my knowledge. And that affects my ability to evolve my API. That's the impact with this, right? And thanks to Nilesh here for observing the difference, right? Now, if you juxtapose Postel's principle and Hyrum's law, they are at opposite corners. Now, if you are looking towards adoption and get people to, like, you be lenient, a little flexible, that's Postel's principle. But if you want to avoid this kind of dubious or rather, confusing situations where people come to depend on certain behavior which is unwritten, then you have to be very, very particular in how you say, this is exactly my behavior. I will not, tolerate any deviation from that. And that's how you can do evolution. So if you are with Postel's principle, you may have difficulty evolving your API. But if you are with Hyrum, then obviously you have adoption issues. So you have to pick your poison, right? Like sort of, but yeah, again, quick recap. We looked at REST, maturity model, and then we looked at Postel and Hyrum's law. Hold these thoughts in your mind because when we do the anti-pattern exercise, I want this to come into that. All of us love Rocky, I believe. I don't know if anyone hates Rocky, but yeah. It's not how hard you can hit, but how hard you can get hit and keep going forward, right? That's technically to me a single image for resiliency even for APIs. The ability to recover from failures and continue to function. Recovering gracefully and expecting the unexpected. That's the nature of running API ops for that matter. Handle or communicate disruptions. So let's take this particular architecture for example. Very, very straightforward order management service. Takes a request to create an order, reserves inventory for that particular order, initiates fulfillment, and then comes back. What could possibly go wrong with the system? My inventory service could be slower, so I wait for it, then I come back, and then maybe my few responses for creating an order are going to take a long time, but that's okay. Fine, we'll move forward. But what if my fulfillment service is completely down? Do I not accept orders? Like, do we not want money? Like, at that point, do we say, it's okay, we are closed today, come back tomorrow? That's not going to work. What if your database is down? These are all issues that happen all the time to all of us, right? Now, resiliency is about how you design your APIs to work around this problem. So, for example, if you're creating an order and you know that these downstream systems could be slow or down, one option is to say, when everything is fine, you will return a 202, 201 and you're done with it. But when something's not working, you can always return a 202, give the order ID, and subsequently the user can get that order ID and see what the status is at. Is it fulfilled? Is the inventory reserved? And whatnot. So thereby the API design can account for the fact and communicate clearly to the user that there is a possibility you might get a 201 or a 202. That's how you design for keeping a resilient design, right? So, yeah. Mechanisms to achieve resiliency, like for example, you could do retries, circuit breaker. If the fulfillment service is already being hammered, you don't want to further bring it down. So we alternate and fall back, return a 202, we rate limit or throttle a fallback, right? And redundancy and load balancing when it comes to, for example, the database instances and all those pieces. Again, this could be a topic in itself, but I'm just calling out certain aspects to think about. These are things the way you traditionally handle resiliency, but the API design can also handle, like, communicate clearly whether this is how my resiliency mechanism works, whether it's a 201 or a 202. Idempotency. Anyone wants to define this? It's fairly straightforward. Uniqueness, okay. Anything else apart from uniqueness? No duplication, yeah. Or rather, precisely, multiple actions resulting in the same behavior, right? This is from the RFC again for safe methods, which is basically intended effect on the server of multiple identical requests with that method is the same as the effect as a single such request. So safe methods in the RFC is get and put. Of course, like when you don't know that you're going to be able to make the request or not, and you want to be able to say, like, for example, put is a very good alternative to post when you know the network is unreliable and you want to be able to repeat it, right? Not idempotent methods, post. If I repeat a post for creating a product, if I retry it, it's not retry safe. The first time it creates product 1, maybe second time it creates product 2. Those are two different resources, not the same resource. That's why it's not safe method. Why idempotency? Fault tolerance. Precisely for safe retries, right? A get or a put is safe for retry. Consistency and low complexity for clients. So client does not have to think about, oh, is my 10th hop going to succeed or not across the network, right? I just blindly fire requests. If it works, great. If it doesn't work, I'll just blindly retry, and it should be safe for me to do so. Improves caching in the context of get, and in line with HTTP statelessness. And all the more predictability, right? You know how it's going to behave. Okay. So that's kind of a logical point, again, of all the topics that I wanted to cover as the basis on which we cover anti-patterns. Quick recap: REST, Richardson Maturity Model, Postel's Principle, Hyrum's Law, resiliency, and then finally, idempotency. All of these points in mind, now it's almost like a pop quiz moment, right? I'm going to put this API design up here. I think most of you are grouped together in tables. So if you could just take a moment, review this and tell me my mistakes or anything that you think is off about my API design. Okay. Okay. Okay, one observation. He's talking about the casing. I have products here and users and orders are lowercase, invoice is lowercase. Anything else? Correct. It's products. This is order. What about it? Order ID? Oh yeah. That's a camel case, that's a Pascal case. Anything else? But what's the overall issue here? There's no create product. Okay. Okay. Fair point. The capabilities are not consistent. Fair enough. Anything else? Yeah, one or all, that's all you have pretty much. But let's take a moment and focus on the initial issues you pointed out, right? The casing and that, like even if you notice, right, there's an underscore here, I think the gentleman over there mentioned, and there's this one snake case. Why is this? Sure, I mean, all said and done, this is still an API, right? It's still level 2, technically speaking, if I want to go ahead with it. Why is this such a problem, this naming convention? What is it affecting? User experience? Readability? Predictability. Both of these, user experience and readability put together, comes to predictability, because I want, the whole point about REST is it's very, very straightforward, right? I take a resource, I know how I'm going to access the single one, I'm going to delete it, how I'm going to create it. If I have casing all over the place, I don't know what I should do. And that's the problem. Unwritten documentation, right? Here I have to sit and write documentation as to exactly what field I should use. It's the best documentation is something that you don't have to write. My personal opinion, right? So, how do you avoid this situation? How do you avoid getting into this? I mean, you cannot say that you should name your APIs well consistently. That's not an answer. Yeah, but that's still, when you say follow, I'm assuming you're saying this is the standard set forth by people, and people, others have to follow it, like look at it and use it. Yeah. That's a whole different hornet's nest. Someone said linters here. How many of you use linters today in general? Everyone almost, right? I assume, because you are using linting for your code, and API to me is also code, right? So, which is why I love these tools, which is like Vacuum and Spectral. Both of these are largely open source. I'll show a quick demo of it. These things accept an open API specification as an input, and you can define your rules as to how your API should look, and it will do the linting for you and give you the feedback, right? So demo time again, at least a little bit of a demo so that we don't all go to sleep, right? So I will quickly run this command and then we'll go into the details of what's happening here. So I'm doing a vacuum HTML report, and then I'm passing it this particular API specification called URL naming convention issue, right? So let me open that API specification. By the way, I'll share this code base with all of you after the workshop, so you can look at it leisure. So here's the API, the one which I just showed you, and here is my outline of that API, and you can see in all ugliness I have that inconsistent naming convention. And now my vacuum linter has run already, and it is giving me an output. So let me go and look at the report, and here's the report. Gave me a bunch of issues, right? Your info section is missing in the description. Check for valid API server definition is missing. A bunch of these things. Where did these errors come from? This is coming from the default linter rules. So when I run vacuum on this, it has a standard rule set called an open API specification rule set. It's running on top of it and figuring it out, right? But maybe I'm not too keen on going about making the open API gods happy. I just want to deal with my naming convention. Can I define my own rules? Certainly can. So what I have here is my own vacuum rule, and this rule basically says that all path parameters should use snake case. I'm standardizing that, and basically here I'm giving the severity of that particular error, and this is JSON path for identifying all of my path parameters. And once I have identified all my path parameters, I can say this is my validation for it, and here is my regular expression to say this is snake case. So now I can go to my readme, I run this with that particular rules, and let me click that out, and it's done. So let me refresh the screen. So now you see only two errors, right? And the two errors are technically only the two issues with path parameter here. So if I open this up, you notice that it says product ID cannot be this, and the other one says order ID cannot be this. So I can quickly go ahead and open the API specification, search for product ID, and name it as snake case. I run my linter again. What just happened? Oh, I didn't change the right one. My bad. I changed something else. Yeah, this is response. If I search for further, yeah, this is the path parameter. So this is what I need to change. Replace that with and the same goes for this. And I run my linter and it come down to one error only. So again, just a very small example, vacuum can go a long way in terms of defining a lot more rules, right? Including your Richardson maturity model levels, you can say which level you have to be at and get methods and post methods and return codes and everything. But technically what I wanted to call out is that one anti-pattern of like, having casing inconsistencies, hyphenations and underscores, plurals and singular, trailing slashes and more. So all of this with a lack of predictability, it is a very, very poor experience for the API consumers and that's the problem and that's how you solve it by using linters to aid your cause, right? Okay, exercise again. I have this particular API, it's got a description also on the top. Take a moment to look at it and let me know what you think. Is it good, bad, ugly? What are your comments? Sorry? It's bad. How so? ID is taken as a string. Okay, valid point. Okay, anything else? Correct. Correct. So why do you think someone's doing this? Like, I know it's an anti-pattern. You shouldn't be having side effects for a get. If you qualify it again from the terms which we learned today, what are we breaking here? Idempotency. ID has to be idempotent, right? Sorry, get has to be idempotent, right? We cannot have like repeatability. Every time we do this, it keeps updating the count. Doesn't make sense. Yeah, exactly. The problem is that design won't even work technically. The reason being, get will be cached. So you don't know whether you're getting the get response from a middleware or from the actual service that you've written, right? So it could even be coming from a local cache for that matter. I'm just saying extremely, but then it won't work. Any other issues? What's the alternative? If all I wanted to do is get an article and for that particular article update the page count, I could split these two things up. The moment you break the single responsibility and the idempotency for that particular endpoint, we get into trouble. So a simple fix there is just don't be stingy about trying to cram everything into a single API, which again goes back to the POX kind of situation, right? What you want to do is respect the HTTP verb, so at least then you get to not break any of the HTTP rules. So the cardinal sin situation, we don't want to get into that. So we just split it up and all's good. Okay. One more for you. This is a search. Step over to the side, there's not much to read here anyway, but what are the issues? Yeah, should be a get, okay, but then I'll give you my problem, right? You see the schema? This is my search criteria. Category has to be electronics, price has to be between this range, this sorting criteria. It's a fairly complicated, what do you call, my search criteria, right? I cannot fit it all into some sort of get. In get, I don't have a body. So where do I cram it? So that's my problem. So that's why I did this. Okay. But query parameter, how many query parameters will you send? So for example, I'll give you a real world use case. Sorry. Certainly. Correct. But then playing devil's advocate, I can say that every single search for me has 50 parameters, extreme case, right? And I want to cram it all into query parameters. And this is the advice that I can give to someone. And then they come back to me saying, no, it won't even work, right? Because some browsers, at least the older ones, would not even have that much, URL length for your query parameters to fit in technically. So it wouldn't even work. But then what about like complex search criteria? How do I deal with it? I cannot send a body. At most I have query parameters and headers, and there's be some sort of reasoning I should come up with to say these fit in the headers, these fit in the query parameters, and then I somehow get the job done. But is that like still okay? Post to get a resource, cacheability is lost, like what Kaushal was talking about. Post is not idempotent, so API clients may not perceive this as a repeatable or safe operation. But that said, what are the alternatives? One alternative that the industry is working on is the query method. So just like you have post, get, put and whatnot, there's a new RFC for, the RFC has been around for some time. GraphQL is another beast, I'll come to that. Yeah, but actually it's a very good alternative, thank you for that. But first I'll finish off the query thing, right? So query is an interesting HTTP method which is soon going to be supported. It's not widely supported at this point. But the moment this happens, I think this problem is already solved for you, because query is an idempotent safe method which has a request body to it, which means you can have more complex payloads, and especially this kind of search criteria, stuff like that, where you want to send more interesting payloads to get other payloads. Obviously query is your alternative. You can read up this and see if what's the mileage it might gather. Now, thanks to the gentleman over here for GraphQL. GraphQL is a very true alternative to this situation, right? Usually when you're trying to cram a lot of work of searching into a single API endpoint, that's when it becomes difficult, right? Maybe internally you have to query 10 other things and aggregate and give it back. GraphQL takes it a lot more. Again, GraphQL actually technically is an anti-pattern, right? Everything is a post in GraphQL. Exactly. But that said, like all fixes or technically patterns end up being a hack, right? And GraphQL at a large level is trying to make do with what is happening and get you the details, but it works and maybe is a very viable option in this case. Someone might argue, why would I go to GraphQL and still use post? I'll just use post with HTTP, but then that's when you take your judgment call. But with GraphQL, you also have to be careful about RBAC and security, because obviously Ebola related issues around security is something that you want to consider. So again, I'm playing very safe, right? I'm just giving you all the problems and then asking you to think about solutions. But yeah, but if you want my opinions, I'm happy to talk to you in the hallways and I can give you exactly what I think about that. But yeah. One option is what query parameters, which all you said, like all of you said, which you could push it into query parameter. One interesting approach I've seen, which at times works, is if I have a search criteria, what I could do is I do a post first and create the search, right? Get the search ID back and then subsequently do a get for that particular ID for that search criteria. So thereby what happens is, if you want to repeat a particular search, you can simply keep calling get and that post is already taken care of, and you're also well within the API design, tenets of HTTP. You're basically splitting up the creation of the search and then eventually executing the search. You're splitting those two things up. Yes, please. Yes. From a customer's point of view, right, the advantage here is if that particular search is technically a repeatable search or something that might happen very often, they get the advantage of doing cacheability. I'm not saying it's the best, right, but if the use case where I've seen this is certain searches are possible to be repeated more than 5-6 times. So there is mileage to it. So if you create one resource, you could potentially get back many times. So that way you don't burn the back end, and for the front end it's a quick response also. But yes, it is a burden on the consumer. Okay. Now let's talk about more interesting stuff. Do you think query parameters can be made mandatory? Okay. Yes. You can validate them. Okay. And that's the query parameter definition from the IETF sections. So we're all sticking to that. What about conditionally optional? It's an optional query parameter, but then conditionally required. Let me give you an example. I have a search criteria here. It could either be price or category. So when it's price, these ranges are mandatory. When it's category, this is mandatory. Category ID is mandatory. So it's conditionally optional, right? So while query parameter itself could be like plainly required, but what about this kind of a situation? Is it good, bad? What's the problem? Yes. Thank you for that, because the next pattern is that I'll come to that. You could make everything optional. In fact, that's what you have to do. He's correct. You have to make everything optional, and then you have to leave it up to the consumer to exercise diligence to say, if I'm sending this, then I'll send the other two and whatnot. But what does this mean for the provider? Yeah. Yeah. Brilliant. Correct. Balance. But technically, you are close to the solution, right? Which is basically, what is the root cause of the problem here? I, as an engineer, am trying to cram two different things, possibly responsibilities, into a single endpoint and have it do too much, right? And like what the gentleman here said, if you split them up, then individually they can have like a very decent API definition, correct? And you could do other alternatives. For example, you could say there is a search slash ID search or search slash something else, I don't know. It's a task based API you could come up with. But the problem here for me is the implementation complexity on the server side. I have to do very, very complicated validation, and I cannot express it in the API specification. As far as the API spec is concerned, everything is optional. So the user can by right say that I'll send anything I want. I'll send category and I'll say price. You have to accept it according to the API spec. And usually in this day and age, we have many API gateways which accept API specifications, basis which they do the validation. And if I pass such a loose API spec into a API gateway, I cannot get the value out of it. That's the problem. Now this is even more interesting. I think close to what you were talking about. Why don't you take a moment and read through it? API helps you create vehicles. You can create cars, you can create bikes, you can create 18-wheelers. And these are all the attributes associated with cars, bikes and 18-wheelers. And it could be any of this, right? So practically what I end up doing is I have a completely optional set of fields. Same answer. Same answer? Do you want to split them up into slash cars, slash bikes, slash 18-wheeler? Do you want to create one? But then how do you, yeah, sorry. Yeah, so the main point is, okay, if I understand what you're saying is, you have one field which defines whether it's a car, bike, whatnot. But then how do you express that for car, these are the mandatory fields in your API? Okay. Correct.
Let's not be very stringent or and very open to accepting.
Got it. You're very close to the solution, so I'll give the solution out in a moment. But then just to juxtapose the point, right? In the previous case, Nilesh said that if we split the endpoint into two cases, search by price, search by category, then it does the job. But then he also brought up the point that how many endpoints can you keep splitting? Here you have the same situation, which is you have vehicles, and if I say car, bike, 18-wheeler, I'll split it into three. Tomorrow, every time I introduce a new one, I have to keep adding endpoints, which is not viable, and that's also the issue, right? Sorry, go ahead, Kaushal. Okay. Yeah, but then if you're saying each one is a resource, that's what I'm saying, right? If car becomes a slash car resource, do I keep creating more endpoints? Cars, bikes, 18-wheelers, trucks, boats, keep creating them? Sure. Fair point. But is there a better alternative? I mean, I do understand it. It makes sense, right? Like if you are in 3 or 4 endpoints, probably best to do that and finish off with it. Okay. So let's look at the API. So this is your API right now, which is, sorry about that. So here's your vehicles, and then if you look at the request body, pretty much you have vehicle type, number of doors, truck size, everything in one single resource, right? What would you do if you were doing like a typical programming language like Java, C#, and you have to deal with this? Polymorphism? Yeah. So practically, even API design allows for that. He was all very close to it. Exactly. Okay, it's called the discriminator. Correct. So this is called the discriminator, right? Let me make this full screen. So the same API, it's slash vehicles. What I have here is something called one-off in the schema. Let me make this a little bigger for you. The spec allows that. So basically, within OpenAPI, you can look for polymorphism and inheritance. So you have one-off, all-off, any-off, and pieces like that. But one-off is primarily very, very useful in this use case. Now I can say it could be one-off car, bike, or 18-wheeler. But how do I determine whether the input is a car, bike, or 18-wheeler? That's when you have a property called vehicle type. And then I say the mapping is such. If it's car, then map it to the schema. If it's bike, map it to the schema, and so on. So what does that schema look like? If I go into the car schema itself, which is right here, the car only has schema pertaining to itself. The number of doors, the trunk size, and the sunroof. And all of them pretty much will be in the required category here. All required. Likewise, when you go to bike, it has only bike related properties and it's required, and that's pretty much it. So now you don't end up in that situation of keeping everything optional. So you end up having like a Frankenstein at the end, right? So you don't want that. So that's where polymorphism is super helpful in addressing this. Any questions so far? Okay. Going back. So this is the exercise and there's a solution. How about this one? Just look at the architecture. I have a load balancer. I have 2 instances of a service A, and for some reason I believe it's okay to return a 500, HTTP 500 for business errors. Am I doing something right or wrong? If wrong, why? It's a security issue also, depending upon what your appetite of how much you expose in 500. But what is the real problem if you return a 500? What is the actual in the flesh problem that happens if you return a 500? Correct. Correct. So what happens? How is a 500 interpreted? It's a crash. So in this diagram, what would happen? If service A instance 1 returns 500 for a business error, what would happen? Exactly. Exactly. So 500 communicates poor health of a service, like what you were saying. So which means as a load balancer, if I am HTTP compliant, I'd consider that to be unhealthy. I'll take it out of rotation. It's not an active status. So for a business error, if I return a 500, even though the server is absolutely healthy, the server will be taken out of rotation. So now what happens? The entire load will go to the other instance, right? Now, again, if there is no business error, even the normal traffic is going to bring it down. That's a vicious cycle, right? So practically, if you end up returning 500, like 500 should never be in the repertoire of, of an engineer who's building an API for business errors, right? If your downstream is down or if you have a database down or something like that, appropriate 500s, right? If it's a 503 or is it a 500 and whatnot, is really, really critical. From an API design point of view, you often see like, 500s for everything you're defining a 500, but really, do you have control over 500? Can you really throw a 500? No, not really, right? Hope that makes sense, right? Like why it's such a serious issue. Okay. What about this one? Good, bad, ugly. It's a products page, returns, values. There's a sort order, there's pagination, and you get back a bunch of results. And of course, you can very well go and say what you want to ask. It's a good design. It's certainly a good design, right? Okay. That's when I have the evil smiles. Something called smart defaults going on there, if you noticed, right? Which is, I'll always give you, sorry? Yeah. Smart defaults, because I want to make it easier. I don't want, like if someone just hits a curl on that URL, I want them to be able to see the results. So I just gave them, it's always going to be in ascending order, and maybe you're going to get 10 items, right? Let's see the impact of that. Consumers may start depending on your defaults, right? Which is screens may be designed to show a max of 10 items. I've seen this with mobile apps. The rich app was designed to show exactly 10 items on the screen. Users may expect that only popular items are at the top, right? That's my sorting order. But then if the front end does not explicitly state what it wants, that it wants the popular items at the top, if I switch my sort order from popular item to lowest price, and suddenly the consumer, the end user is probably going to get affected. So which is why smart defaults, as they are, well they are good, it's sometimes better to make these parameters mandatory. Again, what does this remind you of? Yeah. Correct. So smart defaults, I would not recommend as much as possible. Like, I do understand you want to go through Postel's principle and whatnot, but if you are at the enterprise grade and if you have a large number of APIs, the best thing for you to do is even something as silly as pagination, right? We take it for granted that pagination should always be default and we'll just send it off. But that can have serious impact, which is why I believe like for certain things, if you have the ability to control that, you should make things mandatory and ask from the client explicitly what is it that you want. So that way you can evolve independently, change your sort order and whatnot and stuff like that, right? You're not at the mercy of the consumers. Okay. Who here likes nulls? Sure, sure. technically okay, but sometimes it's very confusing because from an RFC point of view, a query parameter can be made mandatory, but it depends on the server side implementation where you have to have validation for it, right? But the problem is a query parameter by way of how it's implemented and by how middleware usually inconsistently handles query parameters, it is safer not to depend on query parameters being mandatory. I would much rather say if you have to make a query parameter mandatory, much rather prefer going to headers because headers are also for filtering purposes. So a header can be made mandatory and it's easier to validate and communicate intent. So my personal preference, again I could be wrong here, is query parameter is not a good idea to make it mandatory while it can be. I much prefer moving it to headers. Okay. Coming back to my question. Anyone here who likes nulls? I'm glad we are in good company here. So, I mean, this is the best situation, right? You have Boolean, you can only have two possibilities, but you have a third possibility, a Schrodinger's cat called null. You have to deal with the null now. What is null? Is it true, is it false or something else? Right? I'll do one better. You have enum and you have a nullable enum. That's even more of a circus. Because at least in the previous case, I have to interpret it as true or false or something else. But now the enum could be like 20 elements and then I say it's still nullable. The problem with null is the complexity it brings with it, right? How do I interpret my null? And that is always confusing. The provider is going to say the null is true, but the consumer will not clearly understand it. It's like all nulls are evil pretty much in, even in programming languages, even in API design is the same. And specifically in OpenAPI, when you are dealing with a null for enum, this is the documentation, right? Note that null must be explicitly included in the list of enum values, otherwise it doesn't work. It's got all these quirks going around with it, right? So what is an alternative? I want a list of enums. I want the possibility of not sending it. What is the easiest way to get around this instead of using the null? Optional. Enum can be optional. Instead of you either send the obvious values, even a Boolean can be optional. If you do not want to send either true or false, don't send the field, right? Or don't receive the field rather. And that's the simplest solution rather than having to say null is a third possibility. Avoid nullable true, add unnecessary complexity in handling the null. How does one interpret the null? That's the other point which we discussed. Using optional instead is a lot better because it gives you very clear communication. This is what my behavior is. Okay. Coming to this one. I have the slash items. Again, quite similar to the patterns we've seen, right? You had a search based URL, then you had vehicles. Now you have something called items and I have product and service. I could either create a product or a service. Here, what do you think? Is there a problem and if there is a problem, how do we solve it? Fair point. Agree. But that's the tricky bit, right? That the decision making you have to make. So basically here in this case what you're saying makes sense because two entities and basically what you're trying to say is do you want overloading of an endpoint, right? And that's what was happening earlier. So in this case we are overloading the endpoint, so we want to say whether we become a Richardson Maturity Model level 1. In the case of vehicles, like what he rightly called out, at least there was some coherence in saying an 18-wheeler is a vehicle, a car is a vehicle, something is a vehicle. Here item is too generic, a product is an item, a service is an item, practically everything can be an item. So it feels a little weird, right? So that's where now you can go and say this is justified by saying this is looking more like an RPC and you're trying to overload an endpoint, you want to avoid it. Again, I'm trying to give you similar situations and trying to put you in that decision making situation so that you understand that what are the nuances you play into the decision making actions itself. So in this case you are right, Nilesh, so you want to split them up. We've spoken about all these things, right? I personally believe that none of us here or anywhere for that matter want to build bad APIs. That's never the intention, right? No one starts out thinking I want to build a bad API. But API design is someone's responsibility, right? Whose responsibility is it? Who do you think should be responsible and held accountable if something is going bad? Stakeholder is a very generic term. Sorry, you are saying developer, you are saying API architect. It's not a single person responsibility. Any other answers? Solution designer and the developer. Okay. Correct. Fair point. Again, there are no right answers or wrong answers here, right? But then I'll add a little bit more dimension to this. API design is pretty much like a Gamora question, right? Who, when, why, what? Like, what is even API design? So, someone said architect, someone could say an API consumer. I can say API consumers, we are impacted by your API design. We are the ones who should be dictating it. And the providers say, we are the ones who are building it. So, I should have control over how I should build it. You should not dictate it. And someone from security pops up and says like, hey, you're building all this, none of this is secure, right? And then I have not even put all the roles here. If I put in, API ops and then I bring in the SRE people and everyone into this team, practically everyone wants to have a say, but then whose responsibility is it? More dimensions. Should I do API specification first? Or do I do code first? That's an egg and chicken problem. You don't want to get into an argument with someone because both sides will have right points, right? Do I do it individually or like what the gentleman said, do I do it collaboratively so that everyone can be blamed? That's the easy one out. But then the bigger problem or the bigger question in my head is API design just an afterthought or a byproduct? So for example, if I'm the API consumer and I'm saying that I want the API design according to my whims and fancies so that it's easy for me to consume, obviously I'm biasing the API design towards me. The server implementation becomes harder because if the provider makes the first thing, like they write the code first, make it easy for themselves, and then the specification is basically generated from the code, sure enough, it's a very viable option, but the API design is purely a byproduct. We should be under no illusion that spec generation means you have an API design in place. It is just a byproduct of me writing code and then generating spec out of it. The design was not on my mind technically speaking because at least I looked at it only single-handedly. Think about this whole discussion about individual versus collaborative. Like I said, while individual looks like a bad option, at least you have one person to hold accountable for, right? So how do you solve all this? So if you have all these stakeholders, again for the risk of the generic term stakeholder, I am putting exactly the number of people that I personally deal with at a lot of times, which is architects, consumers, providers, and security. They all want to agree that this is the design, right, which is viable, and we all have the organization or the team's interests in mind and want to bring it together. We all agree on this, but the problem is how do we agree? Most of the time I've seen API specifications not being created. It's just an agreement which is put down in a mail, and the most common format I've seen, most of you might agree, is an Excel sheet where I have all the fields and they have the data types and then the mapping of what it can do, right? It's a very good format of API specification, but yeah, unfortunately no one adheres to it and you cannot validate or verify it. So for me, that agreement should be something like a contract, which all of us are held accountable to, which means it has to be in an unambiguous format, which is why personally I prefer putting them into an API specification format. It could be Open API for REST. We largely discussed REST today for the interest of time, but you could be in the world of event-driven architecture for async API, or GraphQL schema definition language, or a gRPC protofile, or even to that matter a WSDL XSD. right? Anything, but it's code and it's not ambiguous. At least we are able to agree on what the API design all of us came together and put together. If you have that and you are able to enforce that into the development process of people, like trying to build applications, both consumers and providers, then you have something called at least an API design first in place, right? So in this case, most of at least my hypothesis so far, and which I have validated through data to some extent, is the fact that the API design issues happen when you look at it from one person's point of view or one lens point of view. Rather, if you do it collaboratively and as a group, early on you can identify such issues and pin them down, right? So that's when what we think about this term called contract driven development, right? How do I avoid this? And that's where a governance model comes into picture in terms of API design. So I already told you that I want to do an API design first. We all come together as a group, decide on what the API is. Again, I'm not too hung up on saying this is not a upfront design waterfall mechanism, right? I'm in an Agile conference and we've come up with it, and I don't mean to say this is a set in stone situation. By starting with the API, it's at an evolutionary level. Every single change is at the API specification level. You go and add a small little endpoint, evolve it. Now, where do you keep the API specification? So this is where we decided, you want a more familiar API developer experience. All of us are engineers. We'd like to use Git or a repository because we are already familiar with GitOps. So it felt most natural to keep it in a central contract repository, but you could keep it in any tool of your choice, right? I think I've seen clients use Redocly or a Swagger Hub or any other choice, but it's practically a source of truth which should be unique so that you're not, it's a central source of truth and single source of truth so that each one does not have a different copy, right? If every one of us had a different copy of our land parcel agreement, it doesn't make sense. So you should have a attested, registered copy, right? So if you have that, you have a pull request process in place, which means I can take the API specification and put it through a linter. You remember the first issue that we saw, the inconsistencies in the naming convention? I could lint that. And I could also take the examples and other things within that API specification and do example validation on top of that information. And someone spoke about compatibility issues. How about breaking changes? And that's where you can figure out and identify and close breaking changes, right? So, of course, we're building Specmatic. I'll just mention briefly what we do here in terms of backward compatibility. So, Specmatic is able to take an API specification and run it as a stub server to virtualize the service, or it can take the API specification and run it as an API test against the implementation, right? So, there's an accidental discovery. What I could do is I can take the newest version of API spec that is being proposed, run that as a stub server, emulating the behavior of what is going to be built, right? I take the existing version of the API specification from the main branch and run it as a test against this guy. If all the tests pass, then you know that it's backward compatible. And that's just like without writing any code, right? None of this requires any code. I'm just doing a spec to spec, backward compatibility check. This is not a diff. This is a full simulation of all the API calls that can potentially happen and then figure out the details, right? Again, like I said, it was an accidental discovery because we had those two capabilities and then we could use this. Then obviously you can have the necessary interested people to review and merge that PR beyond the standard automated review here, which is happening through linter, the backward check, which is happening through, an automated mechanism, a final human in the loop situation to go look at the details here. And then you get it into the Git repository. That becomes your source of truth now, which means now I already told you that you can take the API specification and run it as a stub server, which means now the consumer does not have to wait for the provider to be built yet, right? I can already say, here's my stub server. It's based off of the API specification, which I agreed with the provider, which means now I can start building my system against that with the confidence that they are going to keep their side of the bargain. How do they keep their side of the bargain? I take the same API spec and run it as a test against the implementation. It's almost like ATDD, right? I have an acceptance test driven development situation because my API spec is the acceptance criteria for the service that needs to be built. So I could take this spec, run it as a test against this guy, and verify that they are building exactly to that spec. So which means these two people are not interacting with each other, but they both are being kept in line with the API specification. So I have independently built the provider, the consumer has done their job independently, which means when I go to the CI environment, I could run my unit tests. Of course, that's table stakes. After that, for my component testing for the consumer, I could use the same stub server. It's just an executable. When I say component testing, again, this is more like, I don't want to say service, right? It could be even a mobile app which I'm testing, or a website I'm testing, or another service. That's why it's a component test. And here, after my unit test, again, table stakes, I can do contract testing again in the CI, make sure it's adhering, and move forward. Again, so far, consumer and provider have never integration tested with each other, but they have been kept in line to the API specification itself. They're adhering to it. So now when you take these two people to integration environment, it's going to be a match, right? At least you're not going to have contract compatibility issues. You're not going to have data type mismatches and whatnot. And then you have a clear path to production. And basically that's how you shift left all API design anti-pattern issues to here, to the design stage, much earlier. And obviously you can see the color scheming on my heat map here. It's all green and crimson to the right. I don't want to be in the crimson zone. I don't want to make a mistake which is only discovered all the way over here in production and then go back, and for that matter even integration, right? It's expensive to walk even this much to this side of the screen and figure it out. So which is why I want to shift left to design phase. And the developer experience here, I think if some of you were here for the talk earlier about 10x DevX in this very room, the developer experience is immensely improved because I am not waiting on anyone. I have an agreement and I will work to that agreement, and I have the tooling and the governance in place to hold everyone else accountable to their side of the bargain. So that way I'm not constantly in a distrust situation, right? Reduce time to market. Of course, who doesn't want that? With the microservices, we kind of dug ourselves into a hole where each service can never go to production on its own. I have to put everything in one place and test it, right? And that's not viable. It's impossible, right? The only way I can do parallel development is by being able to have contractual agreements which are enforceable. And that's where this is helpful, because consumer and provider are just two units. A typical service will have a front end, a rich experience layer, a back end for front end, a core service layer, maybe a data repository service layer, an authentication service. All of these things, if I have to put together and test for every single feature, not viable. That's where we need the parallel development. Finally, we do something tricky here. When we do contract testing, the API specification only says I can send an integer or a boolean and whatnot. But if what we have taken as a leaf from mutation testing and property based testing, based on which we generate additional negative tests, where I generate spurious input and see if the application is actually handling the input and giving you back an appropriate 422 or a 400, and thereby it's not really like quietly accepting spurious input and keeping it inside, or worse, throwing a 500. And likewise for the consumer, you can emulate situations like what if the provider is slow, or what if the provider is not returning the value that you're expecting. Testing those with a real service is going to be a pain. But when you're dealing with a mock, an API specification based mock, it's going to be a lot simpler for us. And finally, the API developer experience. How many of you have heard of this term called API drift? Drift. Popular statistic out there, again, you can verify it, which is a large percentage, more than 70% of the APIs that are publicly available out there are not adhering to their own API specifications which are published. Which is a disaster, right, if you ask me in this day and age, because we are all dependent on APIs and for interoperability with initiatives such as open banking and whatnot. And if implementations cannot adhere to the API specification, that's a disaster. So you need, as a developer, as an engineer, everyone needs the feedback as to whether my API specification is something that I'm adhering to. So you need an ability to run tests against your application and see how you're faring, right? So here's a quick report. I'm just seeing if I have the time to show it, but then maybe I'm short. Maybe after the talk, if any of you are interested, I can show you how that's done. And ultimately, I also want to be able to see the dependency charts, right? Which is which service is dependent on what. And why is that useful? I can look at this particular service, user profile app. It's using the log event queue and the validate session app. That's the usability and the usage metrics, right? But you see there are no consumers. Technically, this could be a zombie API or this could be a deprecation candidate. And zombie APIs are also a big problem in the API world because you just have the API sitting and maybe you are not calling it but someone else will, right? So you don't want that risk to happen. So identifying and discovering what's your API usage like based on real development, like usually all the stuff that's running in the CI can give you this kind of a interface, right? So that's pragmatic insights giving you the detail. And ultimately, how many parties are giving both sides of the equation, right? Like I said, if an API consumer is only consuming an API and the producer or a provider is not running the test, then the consumer is at the risk that the provider is not adhering to that spec, right? So that's where you need the metrics to see whether how many operations are only used as a stub or only used as a test. And that governance tells you which ones to go after and help them and adopt that better so that you have a healthy API coverage on the right. So with that, I'll leave you with some good book recommendations and good books in my opinion. Again, people who I have used information from for the talk, like which is basically Hyrum Wright and Jim Weber, obviously many of you might know. These books, I imagine, while they give you a slightly wider angle, the best way to look at it is always in your context. So you will have to play it out in terms of reading all of this, but then looking at it and coming up with your own rule set for what is your API design within your own organization. So that's my recommendation of books for today. I do want to keep 5 minutes for questions so that we can discuss that in the end. It's not just me ranting. So that's me, that's my socials. Please feel free to reach out to me and I'll be around in the hallways later. But now I'm open to questions. Thank you.
Any questions?
Yeah.
It's, I don't know, but from the from the spec perspective, okay, post is supposed to create some resource
Yeah.
on the server side. I had this question a long time, but I have not seen it yet, or probably not read it much about it. But how about upsert operation?
Upsert.
Insert, sorry, not upsert rather. Insert if not available, and give it back. Is that okay to be called as?
That would be a put, right? Insert if, I'm guessing you're saying, correct me if I'm wrong, I'm paraphrasing the question, which is basically, I'm sending you a request, if this resource does not exist, create it. If it exists, ignore it or update it. Is that what you want to do or?
If it already exists, then give it back. But the idea is that over here, the logic of checking whether this already exists or not is not based on ID. It's based on some other parameters which you have to figure out anyway. But that is very domain specific anyway. But if suppose we have that established in some fashion, and assuming the combination of those parameters which identifies the uniqueness of that particular entity it does not happen to be ID for that matter. It cannot be ID. Otherwise, I'm not talking about this question anymore.
Got it.
But where do we put it?
That's a very interesting use case.
As such, but I'm not really sure from the actual standard perspective, where do I put it? Is something which I'm not sure.
See, thinking out aloud, what can happen is you could technically say, first I'll try to get a resource that matches it. If it doesn't match, then I'll create it, right? But if you do the get and before the time you post, between that time, maybe someone else made the API call to create it.
Precisely.
So there's a problem there, right? Now, so if I go against it and say, in one shot, I want to see if I want to, if it exists, then change it. So there, one use case, again, really bad example I've seen is a mutation in GraphQL, because GraphQL again has a querying capability, right, to see something exists. So you can try doing a mutation there, but again, I don't know what is the exact use case. So there are like nuances to be considered here before you actually do it. So if you have exact cases, then we can look at it and discuss. Yes, please. Certainly, that's also possible because you could say, yeah, you could say let it happen. Worst case scenario, it will fail. You will get a duplicate exception, which is fine, I guess. Then you leave it alone that time. Correct me if I'm wrong. In your case, it's a single API call only. He's just assuming that if it fails, then I'll get a duplicate error, and then it's possible, but I'm not sure whether that's the most like, yeah.
So this is really cool because this is a technique I use. I'm a Agile coach when teams have dependencies.
Yeah.
Yeah. So figure out we call it an interface. Yeah, contract.
Yeah.
So that they can work together. But one of the things I notice is that during development, the specs are continuously changing.
Correct.
So how does that work in practice with your system? Because it means that you can continuously changing the contract.
That is indeed correct. So that's a very valid point. So what we do is, like I said, right, the API specification in our use case, we keep it in a Git repository, and that's when the consumer is using it as a mock, the Specmatic, which is the tool which we're using, which pulls the API specification from the central repository directly from Git and uses always the latest version of it. So that way, at any given point in time, it's not a stale version of the specification. If there are changes, you directly push it to the central Git repository via a pull request mechanism. And each party, be it a provider or a consumer, whoever is pulling the specification, they're always getting the latest version or the version that pertains to them. Thereby, if there are changes, you're constantly getting that. And of course, as a result of that, earlier assumptions made on the code, you will have breaking pipelines and whatnot, which you want as a feedback to say that, hey, I built something maybe yesterday, but today the pipeline has changed and it's breaking, so I have to figure that out. And there's some more nuance to it. So for example, when an API is in an early stage of evolution, we have this concept called a work in progress tag, which you can put a VIP tag on the API specification to say that this particular API expect more changes from this. It's not in its complete form, so which means wait for it maybe to be available or use it at your own risk at the moment, and you're on the bleeding edge, sort of. Yes. So like I said, any proposal for changing in the API design would be a pull request to the Git repository. So standard GitOps kicks into place, and whoever needs to vote on that pull request would vote on it, and thereby that's how it's maintained. It's a fairly democratic aspect. Yeah, thank you.
More questions?
Right. Oh, yeah. So thank you. We have goodies here. We have T-shirts and pens to give away. So it'd be great if you could help yourself to the right sizes and pick up some of the goodies for this. And if I may request, Specmatic is also an open source project. So if you could start the GitHub repository, it'd be very kind of you. So thank you, and hopefully see you again. And thanks again to everyone at the conference.
Thanks, Hari, for that wonderful session and making us all think, right after the lunch. Yeah, it was a great indeed. Thank you so much.
Thank you.